we asked 3 companies who are developing per-title encoding technologies to come here, tell us about their technologies, but also tell us about the benefits their customers are receiving by using that technology. And we've got 2 companies who've got it in production pretty well. We've got 1 company who's got it in beta and has some preliminary results for us to share. But I think what I want you to take back is how the technologies work at my level, but really what the benefit of using it is, because I think that's what's most important. And who we have here, we're going to talk in company order. So first we're going to have Steve Geiger, who is Solutions Director of the Americas for Bitmovin. And then we're going to have Assaf Berkovitz, who is Customers and Partners Integration Architect for Kaltura. He just landed last night from Tel Aviv, so he might be a bit jet lagged. And then bringing up the rear is going to be John Dahl, who's CEO of Mux. And before Mux, he founded Encoding, which was one of the first cloud and one of the most successful cloud encoding companies. So he brings a wealth of experience on the encoding side, and they're excited to talk about their new per-title encoding technology. So first up is Steve, and he, again, short presentation on how the technology works, and then more on how customers are using it.
How's everybody doing? You hit the happy hour yet? I did. I brought mine with me. In fact, no, it's okay. All right, here to talk about per-title encoding. I'll go through the methodology and what we do very quickly, and then as Jane said, get to the customer results. So, the goal here of per-title encoding is to optimize the bit rate ladder for every single encode. Now, what that's going to do is allow us to really focus and try to fit into that relatively narrow band that the human perceptual system can see. So if you go above that, you're going to waste a lot of bits in your encodes. You go below that, you're going to see a lot of artifacts that the user is going to pick up on. Ultimately, what this allows us to do is try to reduce the amount of cost, improve the amount of quality that we're going to put into every encode for that title. So we talk about bitrate reduction, which equates to saving money. We talk about storage reduction, which counts to saving money. But then there's also the quality improvement aspect here, which means that the user has a better experience when they're viewing it. Some things that people don't think about often when we talk about per-title encoding is that provides a consistent perceptual quality across the media library. If we're always optimizing for that perceptual band, then you get a really consistent amount of quality across your scenario. It also allows you to get better performance in low bandwidth scenarios because we're not including step sizes that you don't need, and it gets a better quality to those users who are in maybe reduced infrastructures or developing countries, etc. This is how our technology works at a very high level. We do an overall complexity analysis of the file, taking samplings across the whole asset. And then we do what we call a convex hull prediction, which ultimately accounts to doing a lot of sample encodes and using an algorithm to pick where all of those different bit rates and resolutions perform best, and then trying to draw the smoothest curve that we can within that perceptual band. Now, something that we try and also give is not just the optimal set of encodes, but also, everybody has different business constraints, and so we try to give you a lot of flexibility. So setting upper bounds and lower bounds, step sizes, target quality levels, things like this that make it a little bit more business friendly for people who have specific use cases. Get to the good stuff. Here's just kind of a sampling of our results. We have a US premium channel who's doing an international expansion project. They were using a fixed ladder on all of their content, and when they were moving it internationally, they wanted to ensure that they could get better quality and whatever sort of efficiencies they could. Again, emerging markets, different sets of infrastructure, et cetera. So they got an average of an 80% file reduction across their library, because we were able to produce less renditions in some cases, or lower bit rates in others. A premium content provider in JP, which I have some additional slides on.
Did you shut off?
They got a 30%
Yeah.
TCO reduction, which means taking into account the encoding costs, their CDN costs, their storage costs. They pulled that all down, and their quote to us was same visual quality at half the bit rate.
You doing
One of the larger Australian SVOD providers, they use our 3-pass technology and per title and reduce their CDN commits and costs by a quarter. So you can see this works for a lot of different use cases, and in fact here the short form news one was a really interesting one. 60% overall bitrate reduction and a 70% storage reduction at the same visual quality for their assets. So it's not just long form or short form.
Untitled Encoding? Yeah.
So this is that content aggregator in Japan. A little bit more detail
Can
on
you get up that
their
far
use
away?
case. So they use a lot of different technologies, including per title and multi-codec distribution. And this is one customer where the flexibility of per title
Yeah, try to step up that far
really
away.
appealed to them. They had very defined business rules in terms of how many renditions to produce and what they wanted their upper and lower bounds to be. And even within those constraints, they were able to get that 30% reduction in their CDN commit. When we talk about scale, they've done to date 75,000 assets, about 225,000 encoders with the multi-codec distribution that they have today. So here's just an example of one piece of their content. They had 9 renditions fixed. We pulled that down to 6. Average bit rate reduction of 42%, storage reduction of 57% almost, and a improved QE, so reducing that highest bit rate in order for them to serve up a HD level of resolution at 53% less bit rate. So that's what that example looked like in terms of the quality rate. This is PSNR over bit rate. And here you can see that their fixed ladder didn't necessarily perform horribly. It had a nice curve to it. There's a little bit of a dip there once we get a little bit higher. But what we were able to do is pull all that back and make it a little bit more efficient and eliminate some of those step sizes that didn't necessarily bring any justifiable difference in quality. And then on the other end of the spectrum, from long form aggregated content, short form news content. So this customer, we did an evaluation against their fixed bitrate ladder with an on-premise encoder. And they had a 61.6% bitrate reduction and a 69.3% file size reduction. But one thing that was a byproduct of that was a tighter frame quality grouping. I'll show that in just a minute. So these just show kind of their overall BD rate versus their current encodes. Some of that's file size reduction here versus their current. We offered our 3-pass in there, but per title ultimately also reduced it by quite a bit. And when I talk about that frame quality grouping, these violin plots really show that in good detail. And what we're looking at here is the distribution of quality of frames. So per title was not only able to, again, pull that back and make it more efficient, but especially as we gained up onto the higher points in the graph, really tightened that distribution of frames as well. And this is another one that I like to show as well, because it shows that not only we don't always succeed when the fixed ladder is poor. In fact, this fixed ladder, which is in the purple, performed really, really well. However, it had some level of bitrate overshoot there, as you see in the last 3 points that extend far in to the higher bit rates. So sometimes it's even just eliminating those and pulling it back in.
That's gonna be the tool for tomorrow. But this is. You get one? Yes. Yeah.
Next up is Assaf from Kaltura.
He's gonna watch that, you just
We'll
watch
take
that.
questions at the end. Bitmovin, I just want to mention, Bitmovin is exhibiting at the show, so if you have any questions or you want to see any demos, I'm sure you can.
So I want to start with explaining a bit about our kind of, how we call it is content-aware encoding Kaltura. So the implementation we had before we actually implemented the real one is that we first cut the flavor ladder by the source bitrate. So we eliminated all the higher bitrates, which are actually much higher than the source. And for the FFmpeg, when we did the actual encoding of the content, we didn't fix it to actually encode the content with that bitrate, where we actually allowed it to be a little bit flexible to attempt to reach to the max bitrate, but if possible to actually eventually produce a lower bitrate without affecting the visual quality of the flavor. So when we moved to content-aware encoding around 3 years ago, we had a few assumptions that we made, or a few characteristics of our platform. So Kaltura is a cloud platform. We have a lot of content being ingested every day. You can see 10 to 60K a day. We know that many of the sources are actually encoded in bitrates which are, in many cases, is not optimized. The sources are being set with a bitrate which in many cases is much higher than is actually needed. As I mentioned, 10 to 60K a day, we needed to make some calls to we are not able to actually do examination and sampling of all and each and every title. So we had to eventually make a few samples of the source and actually to examine it. So we cannot allow ourselves to examine each and every source. It's a process, each source for the whole length of the source, it's a process that might take a few hours for a high bitrate and long videos. So we actually sample it, and I will explain it in a bit. And even though we make the sampling and eventually reach to an average of the bitrate for that specific source, we cannot allow that average, that number to eventually cause some sources to not be converted in a rate which eventually produce a bad visual of that flavor. So all titles are important. So I will explain that in that slide. This slide. So what we did, we calculated the average complexity, which is the bitrate of each source, by sampling 20 times each video in 20 different places, each video, the video source. And then we calculated the average of those samples. If that average was actually lower, the 50%, and then 50% of that bitrate, that flavor bitrate ladder, bitrate, we actually increased it to be 50%. We didn't want it to get too much low, because we actually were not able to tell to be confident to say that the visual quality will be sorry. weren't able to be confident to say that if the bitrate is less than 50%, the product, the flavor will be in a good, will look visually good to the user. And last, I put an asterisk here. We coupled with a CRF, and the asterisk because it's actually not related to content-aware title encoding. It's actually a fixed number that we set to the FFM encoding command line to produce, and that's value is 23, as you know. And we set it to produce a good visual quality of that flavor. And so that's the implementation of the content-aware. To share a bit of results, a bit about the result. So for the first month, across the entire SaaS, for all partners which are on our SaaS cloud, the average sum of the bit rate of the entries got reduced by 11%. For non-content-aware encoding, the average was 3,400. That's in kbps, or 3.5 megabits per second. Afterwards, it got reduced to around 3 megabits per second. And you can see that for the high bitrate HD flavors, which is 720 pixels, many flavors of the high bitrate, that resolution, were actually not being rendered eventually due to the reduction of the bitrate. So instead of 2.5 megabits, we rendered the 720 pixels resolutions in 1.5 megabits. This is another example for one of our content-intensive customers. 3 weeks comparison before and after the content-aware encoding. Overall, in this period of time before the content-aware encoding, we sampled 6,000 sources. The average source bitrate was around 7 megabits per second. And the average of the sum of the bitrate for these titles was around 10K, 10K bits per second. After the content-aware encoding, you can see that even though the average source bitrate was actually higher, eventually after the encoding, after the content-aware encoding, there was a huge reduction in the average sum of the bitrates, around 17%. And if we look deeper into the different bitrates, you can see that for these two customers, these examples is one for education and NYU. If we look into their average across 1 month, before and after the content-aware encoding, was enabled on their account. There is a consistent reduction in each of the ladder steps of around 10, in some cases even 20%. And the same in Lacana, they are a reseller selling to many different customers and use cases. We can see the same reduction here. This is an anomaly. They started using started uploading high definition content, but the numbers, the amount of content that they are actually uploading in this resolution is very low. But you can see that for the other resolutions, there is a reduction in the average bitrate. And again, this is across the month, so we're talking about 1,000 titles eventually.
is kind of our journey with per-title encoding and where we are going kind of beyond per-title encoding in some ways. Just to get started, I'm going to assume you're all familiar with this already. Netflix released this methodology like 4 years ago. There's been about 500 talks at conferences on this kind of thing. If you don't know, go watch a talk on YouTube. There's a lot of great things out there. We implemented a per-title encoding system. It lets us do things like distinguish between high complexity content, where if you see this red line here, that's kind of the optimal resolution for every bitrate of this video. You end up having very low resolutions for this very complex video to deliver maximal quality of bit rates, versus this low complexity content where you end up with very high resolution to deliver the best quality of bit rate. Simple. We built a system that does this using machine learning. The reason is our platform is designed honestly for a wide range of content, from like premium long form content to user uploads. You can't throw a 75 test code recipe at a user upload that's never been watched. It's just not cost efficient. So we did that, got into production, and then we ran into a limitation. This is the limitation. Per-title encoding, as many people do it, including Netflix, is really designed for one display size. So Netflix does everything they do for, they have a 1080p recipe, a 4K recipe, and a mobile recipe, and they just create the right ladder for that display. But what if you want to deliver the same video to a TV in a living room, and to a phone, maybe even a phone turned sideways so it's even smaller, or whatever that is, and a windowed content on a browser, not even full screen, but a window. What do? So here's what happens if you take this low complexity per-title encoded content and play it on these devices. Here's the ladder, the optimal ladder that you get. Notice a couple things. You stick it 1080p all the way down to 1.1 megabits per second for this video. And then by the time you're down to like a small size, like 540p, you only have 365 kilobits to use. So if you play that video per-title encoded on a 1080p TV, you get a beautiful video. It's 6 megabits per second, or whatever top bit you choose. You have the VMAF. This one, I only have the gradient, I don't have the exact number, but it's definitely in the 90s video. Now if we put that same video on these two displays, what is the AVR? It says my window is only 400 or so pixels wide. So I'm going to grab the next rendition up in the ladder, which is 540p, and you get a VMAF of 50 for these two videos. See what happened? So that's a problem that we wanted to do. There's a few ways to do it. I'll talk about two, and really only talk about one. So one option here is you can use a different AVR ladder for every device, or every device category. It's a great thing to do for Netflix. It doesn't work for everyone else. Another thing you can do is put together a hybrid ladder, and that's what we talk about here. So the question is, what if you want to apply per-title encoding techniques to a mixed set of viewing conditions? Here's how we do it. Here's how we think about it. So you have three decisions to make. Your first decision is what's the max target quality that you want to deliver. Second, what's the minimum size or quality, or however you want to quantify a minimum. Third, what's the number of renditions? So you set these parameters ahead of time. And then you need to gather three bits of data. You gather per-title encoding data, you gather audience bandwidth data, and audience resolution data. So here's what this looks like. So for this example, I'm going to take a max target quality of VMAF 94. It's kind of an arbitrary number, it could be something else, but like VMAF 100 is probably overkill, VMAF 80 is probably too low, so 94 is our target. So we want to deliver whatever bit rate gives us VMAF 94. And 1080p is the largest display we want to worry about. Second, for a minimum rendition, we're going to say it's acceptable to throw away 2% of users. We don't have enough bandwidth. We want to serve the other 98%. And we don't want to go below 240. We're going to have 2 servers. Third, we're going to trim the number of renditions to 5. It's just a decision. Do whatever you want. Fourth, we're going to gather per-title with nobody there. So here, we run our system on 3 test videos that I think I stole from January's test set, so that's okay. And when you run the ladder and find the VMAF 94 point as the optimal resolution for that video, here's what we find. So the first video, 7 megabits per second at 720p. It's a complex little light video. The second one, 1080p at 6 megabits per second. Third one, 1080p at 2 megabits per second. So we've now set our top ladder, the top rendition of the ladder. Now, these last two are a little tricky. Where are you going to get audience bandwidth data and audience resolution? You can gather it from a lot of places. Hopefully you have some sort of analytics on your platform where you're measuring every one of your users and you can query that system to understand what's the composition of your audience. We do it because we have a QE product called Mouse Data, so we have this data for all of our users, and that's what we use in our system. You can use this, you can use your own QE platform, you can use your own internal analytics, whatever it is. But what you need is something like this. You need a distribution of how much bandwidth your users have. So here I've taken two different users. One is TV heavy and one is mobile heavy. This is the cumulative amount of bandwidth. So they all have at least 1 kilobit. And then once you get down to 10 megabits, about 80% of the TV users still have 10 megabits of bandwidth, and about 50-55% of the mobile users still have that. It's kind of a nice slope. I kind of expected to see a little more curves to this, but it's kind of a nice slope here. So you take this data, and then the last thing you want is resolution data. So what resolutions are your users watching at? Here is these same two customers. Here are the resolutions they're watching at. You'll see some modes that are pretty expected. 720p is big, 1080p is big, 360p is big. They share a lot of the same modes just because a lot of devices use similar resolutions. They also have some differences. The TV content has a lot more 1080p and 720p. The mobile content skews a little bit smaller, as we probably expect. Okay, so now we've gathered all our data. We have these two different audiences and these 3 different videos. The next thing we do is we set the bottom resolution. So here we're choosing either the P2, like the second percentile bit rate, which is different for the two audiences, or a resolution. The last thing we do, and this is where I think it gets a little bit interesting, is set the intermediate renditions. And the way that we do it, there's a lot of ways you can do it. Hopefully this theory is something that you can apply the right way for you. But what we do is we equally segment the audience. So maybe 50% of our users are on the top rendition, 2% are on the bottom rendition, or something like that. So we have the other 48% of users that we need to serve with 3 renditions. So we look at what are the resolutions and bit rates that are optimal for the video, that deliver the video at good quality, and that segment that 48% into 3 buckets. So we look at the 25th percentile, 50th, and 75th percentile of the remaining audience, and we find the right bit rates and resolutions at those points. So this is what you get when you run these files through these customers. Some of it's pretty intuitive, some of it's a little unintuitive. Sometimes you have bigger gaps or smaller gaps than you might expect. That might be right, that might be wrong, but it's coming from our methodology of really trying to serve the audience evenly with different resolution, or the different renditions. So let's recap a little bit. What did we just do? We optimize the top bit rate by choosing a target quality and achieving that quality. We use per title encoding methodology to determine what's the right resolution to deliver at that bit rate. We use data to select the bottom rendition based on our business goals. And then we tailor the intermediate renditions to our audience. So that's how we do it. This is all available as generally kind of in a beta format, so you can use it today. We're still working on it. We're going to GA it. We're really confident in everything. One last thing, which is how do you measure? There's 2 ways to measure. The first is looking at the quality of experience of the 2 different methodologies. So this is one of the things that we do in our system. We do a new release of this. We'll sample it within a customer. We'll segment their traffic between the 2 different approaches. And the key things to look at here, one is resolution. Are you delivering the right resolutions in your ADR ladder? And you'll see with the I got this backwards. 1 second. just pretend this is not happening right now. Yeah. Oh, shoot, I just. Yep. Yeah, great. So we have less upscaling with the audience scattering ladder because they tailor the ladder to the actual resolutions that users are watching that and what they have. Downscaling is kind of a mixed bag. This methodology is not optimized to minimizing our downscaling. It's optimized to minimizing our upscaling. So that's one thing to look at. Another thing is rebuffering. You end up with less rebuffering in this methodology because you're choosing renditions that better fit the contour of actual connections users have. Then the very last thing, this is good, this is important. The real question though that we had, and this is something that's still in progress, is how do you actually measure the ladder? You don't use VMAP to measure code ladder. You use VMAP to measure like a single encode. We actually have an open source tool called VMAP Analyzer that you can use to measure the quality of an ADR ladder. So VMAP asks for a single code, what is the quality? What is the quality loss from original to derivative? Our VMAP Analyzer tool asks for an ADR ladder and multiple viewers and an audience. What is the average quality seen? So we look at the audience and we say, about 20% of people are going to be on this rendition and they have these screen sizes. What is the VMAP for that actual user? It's really slow. I don't know if you noticed, but VMAP is really slow. We're doing like hundreds of test VMAP operations. But you can do this and you get a number out of it. Compare two ladders side by side and say this ladder on average delivers 80, and this ladder on average delivers 85, or whatever the results may be. So github.com/buxing/VMAP_analyzer. Take a look, use it, contribute back if you use it.
Okay, we've got plenty of time for any questions. Who wants to start?
Hi, my name is Assaf. I'm from Untitled. Before, in one of your slides, when you were showing the 3 different content, the bit rates that were shown across the same resolution for 3 different content was quite different. So, how do you decide when you get a content, which of those 3 buckets it goes into?
Right. How do we decide what is the right bit rate for an individual piece of content? Yeah, so what we're doing kind of doing a traditional prototype of code what we do. We start with the foundation of test units. We look at every bit rate. First we look at is the quality better or lower if you move resolution up or down. And then second we look at the absolute quality. So our methodology there is to find on that curve what's the point. What is the bit rate that gives you the VNAF of 94? There's just an arbitrary number. In production, in reality, we don't shoot all of this. So what we're doing is we're extracting a bunch of frames from the video, running through a couple layers of machine learning. I'm not an expert, so I'm not going to try to describe it well. But what that does is look it up against tens of thousands of other full prototype codes we've done, find out what it matches, and then it will tell you what is the right bit rate for that video to achieve that goal.
Just on that point around downscaling on lower end mobile devices and things like that, from my understanding, the concept of a point in a pixel is decoupled on most devices. You have like 432 points, but that's 2x pixels. And the device will actually take a representation of the video that's equivalent to the pixels, not the points. And also on the web, you can just force it to use a higher resolution representation than what the viewport is and simply do the built-in downscaling in the browser. Have you looked at that, or have you found that it's actually much worse and it's better to re-encode?
Yeah, that's great. I think the difference between the physical pixel density and the logical pixel density is really important, and we should be aware of that because every device has different representations. If problem that we have is we're a platform. So we have people using uncontrolled video players who want to play that video. If we were just a single provider, we could do that. We could make sure that our AVR ladder knows to go up the ladder more than it maybe should. Some AVR ladders don't respect the physical density of the device. They'll look at the CSS density in the web and say this is only 300 pixels, even though it could be 600 pixels on a retina display. So because of that, we have to think one level beyond what you can do. We have to make it not error prone for our users. Does that make sense? Yeah.
We have a pretty wide range of customers who use a wide range of players, but from our playback perspective, we offer a lot of tweaks to the AVR algorithm to look at and weight different aspects and consider that screen resolution or to exclude that. So those are the options that you have from a playback perspective when you're looking at it.
So YouTube has trained us to know that 1080p is always better than 720p, but with per tile encoding, it doesn't always give you a 1080p, even for 1080p content. What do you do?
Yeah, I mean, in many cases, it's not worth it, right? And so we're trained as people to think better resolution, better quality, but that's not always the case, right? So we need to untrain our users or obfuscate that from them and make the best decision for them. Those are the options that you have available to you. But I really think that people will start to learn down the line that resolution is not equivalent to quality.
Another thing we've done is start to use language like high, medium, low instead of 1080, 720, 540. Doesn't work for everyone, but that's really what you're trying to get to.
Any other questions?
This question probably goes for Bitmovin and Kaltura. You explained how and how much savings you have generated. How do you convince your customers, or do you do any quality of experience measurement, concrete numbers to tell, hey, we saved you 30%, but how do they check they really didn't lose on quality?
Yeah, I mean, we don't couple our products, so we can't always tell them hey, you need to go use our analytics in order to do this. We'll make the suggestion, right? But we encourage them to use whatever platform they have in order to give us feedback. And we go and we test this in our own environments and try to make sure that we're making the right decisions when it's coupled with our player and our analytics from a per title perspective. So I think a lot of the things that John said were exactly on point. And when you have that data available and you can use that to reinforce decisions, that's what we ask our customers to do. And that's why we've built the flexibility that we have into the per title model so that you can constrain it in the same sorts of ways that John was talking about with your upper bounds, your lower bounds, your step sizes, or target bit rates, or target quality. So there's umpteen different ways that you can wrap these configurations around per title to do very similar things. If you have that data, we'll help you pull that data in and make those decisions in order to better serve your individual customers. Because absolutely right, at the end of the day, we can make the best decisions we have for the quality and bit rate for that asset in the absence of any other data. But everybody's audience is different, and if you can use that data to influence those decisions and cap the bit rates in a way that really reflects your audience, or perform the step sizes that you need in order to meet the distribution of your audience, then you absolutely should.
So basically you're saying use your business metrics and compare those assets to the new transcoding ladder and compare the results. And if you get new business metrics that are better, that means we're making the right decision.
Yeah, and your audience isn't going to be static, right? Things will change over time, and so you need to make that evaluation for yourself. As things progress and your audience grows or changes, how you want to reflect that in your encoding down the line, because the choice you make today may not be relevant 6, 9, 12 months from now.
I want to answer that as well. So when we started experimenting with the new algorithm for the content-aware encoding, we started by enabling it on a few high-intensity, content-intensive customers, during which we did both PSNR testing of the quality and also visually. We actually looked into the products, the flavors, to see that there is no visual degradation. And after a certain period of time, when we felt confident, and we enabled it across all our customers on our SaaS, like around 1,000 customers. There are some exceptions where they have a very unique conversion ladder, but for the most, it's got to turn on by default. And the goal eventually is to lower the bitrate of the flavors. It's not saving space. It's delivering a good quality, to keep the same visual quality of the flavors, but lowering the bitrate. So it's reducing the chances of buffering and etc. for the end users. And we didn't hear any complaints since we turned it on by default. So yes.
So Assaf, did you just say that your customers are using per title by default at this point?
Yeah.
Okay, Bitmovin, I guess it's still a decision they made proactively.
Yeah, it's an option for them.
Okay. Okay, any other questions? All right, thank you panelists, great job.